Looking at WAMAP assignment 5.2, I'm now starting at number 7 here. In number 7, all of a sudden we start seeing an equation that we may not necessarily recognize. Here we have the cube root of x, which is probably not something that you're familiar with graphing. But on the plus side, it actually gives you what the graph looks like right here. And that's kind of the idea about this assignment, is it's being able to apply rules that are applied to familiar graphs and being able to apply the exact same ones to brand new ones. Because the whole idea is that all these rules about the shifts and other transformations we get into later, they apply to every single different function type all the same way. All right, so in this case, we know that the graph looks like that. So I'm going to have to come down here, and I see that I'm going to be graphing f of x plus 2. And so if I'm going to be graphing f of x plus 2, I need to recognize what the 2 is doing. Notice the plus 2 is inside the parentheses, so that tells me that it's shifting it in the x direction, because anytime it's with x, it moves it along the x, and plus actually moves it to the left. So what we're going to be doing is we are going to take this exact same graph that we have here, except we're going to move the whole thing to the left 2 units. So note what that graph looks like. Kind of like an S-shaped graph, right? Well, we got to find that one down in this list of possible graphing types down here. So I'm looking for something that looks kind of like that, and it looks like there's going to be a winner right here. And so that's the one I'm going to be using. You'll notice there that it's got a couple little red dots on it. Those show where the points are going to be when you plot them. So you notice that one of them's right in the middle there. That point is basically, if we're taking a look at the original graph, that very first point that we're plotting is the one that was plotted right here at 0, 0 originally. And so we need to figure out, where did that go? Well, remember that we moved the whole thing left 2? That then means that my very first point is going to be just left 2. And so plot the dot there, and then notice what's happening as I'm moving it around. The whole thing is moving in different directions. Well, I need to know where this next point goes, because it really could be anywhere, and we'd still have that S-shaped graph. In order to know then, I can just go back up here. And I know that that very first point that I plotted was here at 0, 0, but I need to plot one more point. And I need it to be at a nice, pretty number, because of course the points are locking onto the holes, right? So as I take a look at it, I see that there's a point right there at 1, 1. So I can use that. In case you're curious if there's any other points you could use, yes, there's also one right here at 8, 2, because the cube root of 8 is 2. And there's also ones here at -1, -1, and -8, -2. So all of those would technically work for your second point. I'm going to make my life easy though and just use the 1, 1. So I'm going to go with that point where it is moving over 1 and up 1 from the starting point. Everything is relative to that starting point. And then once I've done that, that graph is done, and I can go ahead and submit it. My next problem actually looks a bit like the last one, except also flipped around. In this case, you'll notice that my original equation is x cubed. And my graph still kind of has a S shape to it, but it's different because the last one was much more S-like. This one's more like we took our S and turned it on its side. So that's x cubed. Now you know what the graph looks like, but really what you really need to know is how are we transforming it in this particular problem. Notice we have f of x minus 6 here. The minus 6, it's inside with the x, which tells us that it's going to be moving it in the x direction, and minus moves to the right. So this graph will be moved to the right 6 units. So I literally am taking the exact same graph that I have up here, and I'm just trying to copy it where it's going to be over 6 units instead. So I'm trying to replicate something that looks more like that. Well, first thing I need to do, look down below, find the graph that looks like that. And it looks to me like that's going to be this one right here. And so the first thing I'm going to do then is I'm going to go ahead and select that graph. And then once I do that, then it's a matter of where does that first point go? Remember, we're moving to the right 6. So I put my first point, right 6. From there, we need to know where to put the next point. Notice that this graph also includes the point 1, 1. So if I take my next point here and go over 1, up 1, then I end up matching it. So again, I'm taking a look at the original graph up here, and I'm looking to see what points does it include, and I grabbed that one. That's the one that I just plotted. Although once again, if you are wondering, are there any other points you could choose? Yes, you could also do 2, 8, because 2 cubed is 8. You could do -1, -1, and you could do -2, -8. Any of those would have worked. But you only need one of them, so I use that one, and then I can move on. And then finally, my last problem that I'm going through in this particular recording, it happens to be another x cubed graph. So I already saw what the shape looked like and know how to deal with that. So then the question is, how's it being transformed in this one? In this case, we have a -4, and notice the -4 is hanging on the end. It's not in the parentheses, it's not with x. Therefore, that means that we are moving it 4 units vertically. We're moving it up and down. Minus moves it down. And so this is going to be the same graph that we were working with last time. So I'm going to go down and select that. Except this time I'm starting down 4 instead of moving it over. So I'm going to start by going down 4. And then just like last time, I'm just going to go over 1 and up 1 to get to my next point. And there you can see that we do indeed have the exact same shape of graph, just move down 4. That one is now done and ready to submit.